Welcome. Let's explore the Liskov Substitution Principle. Every subtype must replace its base type without surprising the caller. Meet two shapes, rectangle and square, subtypes that keep their promises. Consider this rectangle class, with setWidth, setHeight, and getArea returning width times height. The resize method sets width to 5, height to 4, then asserts the area equals 20. For a plain rectangle, this assertion passes. But will every subtype keep that same promise? Here a square inherits from rectangle, overriding setWidth and setHeight, so both sides stay equal. We pass it into the same resize method. But now getArea returns 16, not 20, and the assertion fails. A square cannot keep rectangle's promise, so this inheritance lies. Look at these overridden setters. The base type promises width and height move independently, but squares secretly links them. That's the conflict. Strengthening preconditions or weakening the base types guarantees breaks substitutability. Stop forcing square to be a rectangle. Define a shape interface with a single area method. Make rectangle and square separate implementations, each with its own fields and constructor, no shared mutable setters. Watch the client loop total area across a list of shapes. Rectangle and square swap in freely, no surprises. Substitution stays safe and the caller stays correct. Look at the diagram. The shape interface sits at the center with an area method. Rectangle and square both implement shape, joined by implements arrows. Any shape reference can safely hold either box. Notice the old arrow, square extending rectangle, now fading as we remove it for breaking the principle. Compare the two versions. Before, square extends rectangle. The setters are coupled and the resize assertion fails. After, rectangle and square are immutable and implement shape with area, and the client just sums the areas. Watch. The assertion that once failed now finally holds. The Liskov substitution principle ensures subtypes replace their base type without breaking callers' expectations. The result, reliable polymorphism, no hidden special cases, safer extension. Base type, honest subtype, trusting client.